There we go. So this is 6-2, like I said, and we're going to be talking about inverse functions. Inverse functions and relations. And please, 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 please do not overthink this lesson. This is one of the easier lessons in this unit. So let me remind you a definition here, because I'm going to start with the relation part. A relation, by definition, if you remember, is nothing more than a set of ordered pairs. Okay, it's a set of ordered pairs. So, for example, I could do 3, 2, 1, 4, -7, 3, 9, 1. By definition, this is a relation. Okay? An inverse relation, and there's a real wordy definition in my textbook. I just want to show you that the inverse, we get an inverse relation by exchanging the x and y coordinate. Thank you. The x and y coordinate of each ordered pair. Ordered. Of each order. Is this light right here bothering you guys at all? Okay. Of each ordered pair. So if I wanted to find the inverse of this relation, all I'm going to do is switch the x and y's of the ordered pairs. So it's going to be 2, 3, 4, 1, 3, -7, and 1, 9. Okay, so you just change the x and y. So if I give you a set of ordered pairs and I tell you to find the inverse, or tell me the inverse, all you're going to do is switch the x's and y's. And there's not a whole lot more explanation I can give on that. Does everybody understand that? Because I'm going to give you some of those on the homework and on the quiz Friday. Now, this, we're getting into some functions here. You guys remember this was function notation, right? Talked about that back in unit 2, I think. So this is function notation. That's how we show function notation. Inverse function notation, okay, the inverse function notation is written like this. We put a little -1 exponent there. I'll move it over a little bit. Okay, so this means inverse. This means regular function. Okay, that's just some housekeeping stuff for you to know. So if you see a -1 in the book, that means you're looking at the inverse of the function. Okay. And graphically, what that means is if I have a graph where the line's going this way, okay, like this on a graph, then the inverse would look like this. But I'm not graphing them today. We're going to solve today. Now, finding the inverse algebraically, that's what I really want to focus on. That's what I want you to be able to do. So that's what I'm going to get ready to show you. So this is finding the inverse algebraically. This requires that you remember the order of operations and inverse operations. So this is finding the inverse algebraically. Again, don't overthink this. Okay, some of you will, but please don't. Here's our first function. I'm going to put it in function notation. F of x equals 2x minus 5. I want to find the inverse of this. Well, finding the inverse is the same as finding the inverse for those ordered pairs. I switch the x's and y's. Okay? So to find the inverse of this function, switch x and y. Okay? So you're going to want to rewrite this. Instead of f of x, go ahead and put the y there, because remember this, f of x equals y. F of x equals y. So I'm going to change this y, or this f of x to y, and then I'm going to do 2x minus 5. So step 1, which is right here, I'm going to switch the x's and y's. And what that looks like is this. So everybody do this. It's going to become x equals 2y minus 5. So all I did was change place with the x and y. So everybody clear on that? And now step 2, once you do that, solve your new equation for y. Okay. So I've switched my x's and y's, and now I'm going to solve this new equation for y. So I'm going to start by adding 5 to both sides, because I want to isolate this term. So I'm going to add 5, and that's going to give me x plus 5 equals 2y. And then I'm going to divide by 2, and that's going to leave me y equals x plus 5 divided by 2. And guys, this is the inverse. That's the inverse. It's the most complicated part of this is sometimes the equations get a little bit tricky to solve, but for the most part, that's it. Switch the x and y's, and then solve the new equation for y. Now I want to get into a couple different looking ones, because some of these are pretty challenging in the homework. So let me show you another one. Okay, let's do this one. I'll start here. F of x equals x squared plus 1. So I guess if I was going to number it and make a list, I'm going to tell you step 1, change that f of x to y. Okay, that's going to be step 1. So y equals x squared plus 1. And step 2, switch the x and y. So I'm going to do x equals y squared plus 1. Then step 3, solve new equation for y. So in solving this new equation, what I want to do is I'm going to subtract 1 from both sides. And that's going to give me x minus 1 equals y squared. And then to undo a square, you square root it. Okay, so to undo this, I'm going to square root. So I'm going to square root both sides. When I square root y squared, all I'm left with is the root, which is just y. So I'm going to get y equals the square root of x minus 1. So this is your inverse. And you don't have to use inverse notation. You can leave it as y equals the square root of x minus 1. A little bit better. What questions do you have? Yes? I'm sorry, you're asking for the square we don't do what? Oh, we're just okay, so we're just switching the variables. I'm not switching any number, any exponent, nothing. You're just switching the x and y's. So for example, if I gave you this problem, and we're not going to solve this. If I gave you something that looked like this, y equals x third plus 1. I'm making this as obnoxious as possible because I want to illustrate my point. I'm not going to solve this, okay? I'm just showing you. I'm only switching this and this. Everything else stays. So it's going to be x equals y to the third plus 1 minus 2. Okay, so you just move the letters. Okay. Any other hopefully that answered your question. Yes, Dylan.
Why did we get the square?
In this problem, it was
No, not the square, the square root.
to undo a squared number, the inverse of that is always a square root. So if I want just to get the x, I have to use this symbol. Any you guys are asking good questions, so any other questions? Anything else I can clear up? So my goal is that, and this is the only two things I want you to be able to get from this lesson. I want you to be able to look at ordered pairs and write the inverse. So just switch the x's and y's. And I want you to be able to algebraically find the inverse. Okay. Your homework is on Canvas. You were doing 2 through 26 even. 2 through 26 even. It's on Canvas. I've marked out some problems I don't want you to do, and you are not graphing. And guys, I'm sorry, is today hat day? Okay, sorry. Other than me being a Nazi in the hallway, that's really the only rule I actually enforce in my classroom. You guys. So. If you have questions, ask. I will help you. I'm going to post this video online, so if you